Well, hi there, and welcome to this screencast on impulse. This is the continuing screencast in a series from Topic 2 in IB Physics core curriculum. Topic 2 is on mechanics. So in the screencast, we'll define impulse, and we're going to find out its relationship to momentum. So let's get started. So impulse is a force applied over a certain time. So in math language, you would say this. Force times time, this deserves a box. Now the force we're talking about here is an average force. If you think about it, you push on something for a certain amount of time. What really matters over that time interval is the average force with which you push. The units of impulse, if force is in newtons and time is in seconds, then we have an impulse in newton seconds. Take a quick example. So we have a constant force of 5 newtons and time is 0.4 seconds. The impulse is 5 newtons times your 4/10 gives us a total impulse of 2 newton seconds. So let's talk about how impulse is related to momentum. It turns out they have a very intimate relationship. Let's see how. So you got to remember, this is Newton's second law of a net force causes objects to accelerate. Let's rewrite this for a moment, and we're going to manipulate this one over here. So instead of acceleration, we can write change in velocity over change in time. Now let's rewrite that down here. And let's bring the time over to the other side. So time comes over here, and we'll slide down velocity. Now let's look at this for a moment. We have force times time. This is impulse on this side of the equation. And over here we have mass times the velocity. It's change in velocity, but mass times velocity is really what? Well, that's momentum. And this delta gives us, and since it's change in velocity, this is really change in momentum, assuming mass stays the same. So this side of the equation, we can also just say change in momentum. Well, this deserves a box by itself. In common language, this would say an impulse causes an object's momentum to change. If you think about that a moment, okay, an impulse, if I apply a force on some object over some time, I can expect its velocity to change. So that kind of makes sense. In fact, it's a lot like what we said here with Newton's second law. In fact, it's just a different way of saying it. Another form of saying this is force times time. Here's our change in momentum. We can write it this way. This is our final and initial velocities. In terms of units over here, we have Newton seconds on this side, the left side, and on the right side we have units of momentum. A Newton second is equivalent to a kilogram meters per second. Now if you break down newtons into its base or fundamental SI units, you'll see this is true. You can also say that this forces produce change in momentum over a given time. There's a rate of change in momentum. Now this is a net force, and this is just another way of saying Newton's second law, really. In fact, this is how Newton himself said it. Let's have a numerical example here of an impulse. Here we have a tennis ball. It has a mass of 60 grams, and it hits a racket at 6 meters per second. It rebounds in the opposite direction at speed of 4 meters per second. We want to know the impulse that's given to the ball and the racket. So we have, here's a picture of the situation. Ball comes in, has a velocity to the right here of 6 meters per second, comes back with a velocity to the left of 4 meters per second. So the impulse is force times time, but it also is mass times a change in velocity. So even though we don't have the force here, we do know that the momentum before and after. That can tell us the impulse. So we have mass times change in velocity. Mass is this. Change in velocity, we need to be careful with signs. It's final minus initial. So final is -4, subtract a +6. We get -10 here. So multiply this by 10, we move the decimal place. So we have an impulse of -0.6 Newton seconds. Now that's the impulse. So how about it's the tennis ball and the racket both. Why is that? Well, I can give you a hint. Do you remember Newton's third law? If we have a force on the racket, what's the force on the ball? We know it's equal and opposite to each other. So if the forces are the same, but opposite, then the time of collision, well, that's got to be the same. They're in contact with each other for the same amount of time. So the force is the same and the time is the same. Then the impulses are going to be the same. Now you can argue that the impulses should be opposite. right? Because they're forces in a different direction. The magnitude for both would be 0.6 Newton seconds. Okay, let's talk about if the force on an object is not constant. So up until now, we just been having a constant force over some period of time. Well, what if you apply a force that's not constant over time? And this is usually the way things happen, in everyday life. So let's assume that we have this sort of relationship of force with time. It looks like that. Well, if we had a constant force, say like up here at 6, force times time would give us impulse. Force times time in this graph is the area under here. So we would have something that looked like that. So for this whole rectangle, we would have an area of 6 times 0.3 gives us 1.8 Newton seconds. That would be the impulse under that top line here, constant force. Well, we don't have a constant force. We have this area. Can you find the area of this triangle? Well, we know the formula for the area of a triangle is half times base times height. So it would be just half of what we had before. In this case, it's 0.9 Newton seconds. Now, what about the average force? The average force would be halfway up. So it would be here at 3 newtons. And if we looked at the area under this rectangle defined by the green line, we would have an equal area. So the areas of this triangle and the area of this rectangle are both 0.9 seconds. So we can think of the impulse delivered by this funny triangle shape as the same as the impulse delivered if we had a constant force that would be equal to the average force over this time. And that can help simplify problems. That's your screencast on impulse. Okay, bye.